Hi there. Today we're going to discuss proportional relationships. Objectives. We're going to write and solve proportions today, and we're going to use unit rates to write equations. Our standards are we're going to recognize and represent proportional relationships between quantities, and then we're going to identify the constant of proportionality or unit rate in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. And we're going to represent proportional relationships by equations. Vocabulary you need to know for today is proportion and cross products. Write and solve proportions. A proportion is an equation stating that two ratios or rates are equivalent. So for an example, 6 over 8 equals 3 over 4. These two are ratios and they are equivalent. The products A and D and B and C are called cross products of this proportion. The cross products of any proportion are equal. So this is really important. So the cross products are diagonal from each other. So 6 times 4 is 24, and 8 times 3 is 24. So if ever you have a proportion, you can multiply the numbers that are diagonal to each other, and they are equal. You can use cross products and proportions to find missing values. How to solve proportions. Make sure you write this down in your notebook. Step 1, set up your proportions if it's not done so already. So this is in the case of like word problems or real life examples. You have to set up your own proportions. They're not going to set it up for you. Step 2, find the cross products. Remember, the cross products are diagonal from each other and they're equal. We're going to multiply the cross products. Then we're going to divide both sides of the equation by the number being multiplied by the variable. And our last step is we're going to simplify. I'm going to show you two examples of this so that when we move on to real world examples, it'll be a little easier for you. All right, so my first example is 2 over x equals 3 over 9. These are two ratios and they're set equal to each other. So the first thing we're going to do is we're going to find their cross products. We're going to multiply their diagonals. So 3 times x is supposed to equal 2 times 9. It's very important that you write out this step of the multiplication. Next step is you're going to multiply. So 3 times x is 3x, and 2 times 9 is 18. Now we have this equation, 3 times a number is going to equal 18. So we're going to divide each side by 3, and we're dividing each side by 3 because that's the number being multiplied by the variable. And then what we're going to do is we're going to simplify on both sides. So this 3 and this 3, they simplify out. And then 18 over 3 is going to equal 6. So if I substituted 6 where the x was, these two ratios are going to be equal. Here's my second example. G over 3 equals 20 over 12. So again, our first step is to find the cross products. So we have 12 times g is 12g, and 3 times 20. So it's important that we do our multiplication. All right, so the next step is we're going to multiply. So 12 times g is 12g, and 3 times 20 is 60. So now what we're going to do is we're going to try to solve this equation. What number times 12 is going to equal 60? We're going to do that by dividing by 12 on both sides of the equation. Now we're going to simplify 12 over 12, and we're going to simplify 60 over 12. And when we simplify, it equals 5. So 5 over 3 is going to equal 20 over 12. Remember, solving proportions does not mean that the answers will always be a whole number. Sometimes we will use proportions to solve real-life problems, and that's going to include something like money, distance, and they're not always going to be whole numbers. All right, example number 1. After 2 hours, the air temperature has risen 7 degrees Fahrenheit. Write and solve a proportion to find the amount of time it takes at this rate for the temperature to rise an additional 13 degrees Fahrenheit. All right, so this is the part that I'm talking about where you're going to have to set up your own proportions. So you have to find two things that are in a relationship. So we know we're going to have hours and we're going to have temperature. So They said let t represent the time in hours because you're looking for the amount of time. So what we're doing is we're just substituting a variable for something that we don't know. So here we set up temperature and time. Notice when we set up this proportion, we kept temperature on top for both sides, and we kept time on the bottom for both sides. Okay, that's very important because you have to be consistent. So here we said temperature was 7 for 2 hours. The temperature they want to increase is 13 degrees. That's why we put it on top with temperature. And we don't know how long it's going to take, so that's why we put T for time, because we're not sure. All right, so this was our original proportion, 7 over 2 equals 13 over t. Now we can start solving this proportion like before. Remember, the cross products are equal. So we know that 7 times t and 2 times 13 are equivalent. So I found my cross products. Now I'm going to multiply. So 7 times t is 7t, and 2 times 13 is 26. Now I can start to solve. I need to know what number times 7 equals 26. And how I'm going to do that is I'm going to divide by 7 on both sides of the equation, and I should get a round or an estimate of 3.7. So what that means is it's going to take about 3.7 hours to rise 13 degrees Fahrenheit. So again, this is an example of a real life situation where the answer didn't end up to be a whole number and we had to kind of round. So just to review the steps, find the cross products. You're going to multiply. You're going to divide each side by the number that's being multiplied by the equation, and then you're going to simplify in the end. Okay, example number 2. If the ratio of type O to non-type O donors at a blood drive was 37 to 43, how many donors would be type O out of 300 donors? Okay, this one's a little tricky because they gave you two numbers, which was type O and non-type O, but then they want the total amount of people out of 300 donors. So what we're actually comparing is not type O to non-type O. We're comparing type O to the total amount of donors. So this is how we set this up. Type O was 37. Total donors is actually the total amount here, which is 37 plus 43. So the actual fraction or ratio of type O to total was 37 out of 80. We're going to use this in our proportion. So we're going to write a proportion, excuse me, that lets T represent the number of type O donors, because that's what we're looking for. Okay, so now we have type O donors is 37. Total donors was 80. We got that from here. We want to know how many is type O, so that's why we called it T. And the total donors that they gave us was 300. So now we're going to use this proportion to solve. Okay, so here we are. Now we know that we have to set up our cross products. So 80 times T and 37 times 30. Now it doesn't really matter which side the variable is on, whether it's the left or the right, because it's equivalent either way. So we found our cross products. Now we're going to multiply. So 80 times t is 80t, and 37 times 300 is 11,100. Now we are going to divide by both sides of the equation by the number that's being multiplied, by t. So we're going to divide by 80 on both sides. And the answer we should get is 138.75 equals t. Now what we have to remember, boys and girls, is this is 138.75 people. So just by judging by what kind of answer we're going to get, we can't say that there's 138.75 people. We're just going to say it's about 139. Use unit rate. You can also use the unit rate to write an equation expressing the relationship between proportional quantities. So what we're going to do here is we're going to take it back to our previous lessons, and we're going to find the unit rate. So the first thing we're going to do is find a unit rate. We're going to create an equation using the unit rate. We're going to substitute values, and then we're going to solve. And then I have a little reminder, don't forget the units. All right? Make sure you write this down in your notebook so you have something to refer to. Okay, so example 3, Olivia bought 6 containers of yogurt for $7.68. Write an equation relating the cost, C, so they're telling us what they want us to use for the variable, C is for cost, to the number of yogurts, Y. How much would Olivia pay for 10 yogurts at this same rate? So this is a little different because they don't actually want us to use proportions. They want us to create an equation. So again, the first thing we're going to do is we're going to have to find the unit rate. Okay, so we know that it's $7.68 for 6 containers. So I'm going to set up the cost in dollars over containers of yogurt. So I have 768 over 6, and that equals $1.28 per container. So that means the cost is $1.28 times the number of containers of yogurt. So if you wanted to buy 5 containers of yogurt, you would multiply 5 times 128. If you want to buy 20 containers of yogurt, you would multiply that times 120. $1.28. So our equation is going to be C, our cost, is equal to 1.28 times Y, because you're multiplying $1.28 times the number of yogurt, containers of yogurts. So this is our equation. Now we're going to take our equation and we're going to substitute some values. So we know that we want 10 containers of yogurt. So instead of Y, I'm going to put 10. We're going to multiply, and then finally we're just going to restate. The cost for 10 containers of yogurt is $12.80. We're going to have one more example. JC bought 8 gallons of gas for $31.12. Write an equation relating the cost C, again this is our equation, our variable cost C, to the number of gallons G of gas. So our two equations are, variables are C for cost and G for gallons. How much would JC pay for 11 gallons at this time? All right, first thing we're going to do is we're going to find the unit rate between cost and gallons. So we're going to set up the ratio of cost over the number of gallons. So we had $31.12 for 8 gallons. So we divided that out. So that means he paid $3.89 per gallon. Okay? So what we're going to do is we're going to say if you want to find out the cost of a certain number of gallons, you're going to multiply $3.89 times the number of gallons. So we're going to take this equation, we're going to substitute our given values. They wanted to know for 11 gallons of gas. So we're going to replace the G with 11, not the C. So we are going to then multiply it out, so 42.79, and then we're going to just restate the cost for 11 gallons of gas is $42.79. So today what we learned is we learned how to solve proportions, we learned how to set up and solve proportions, and then we learned how to create equations and solve for values. I hope that video was helpful. Thank you. Bye.